If you look at this circle, as I twist it away from you, the viewer, it becomes an ellipse. This part here stays constant as the degree of the ellipse changes, whereas this part gets smaller and smaller as it twists away. So that is the major and minor axis. So when you have a circular perspective, it's called an ellipse, and it has two primary axes. It's got the minor, which changes by the degree, and it's got the major, which stays constant. So as it twists away from the viewer, I can draw some roughly parallel lines here. So if I was to make that a more narrow degree ellipse, this major axis would stay constant, whereas this minor one would decrease. And conversely, as I increase the size of the ellipse, well, the minor axis would grow bigger, but that major would still stay constant. As a circle changes the angle to the viewer, you get different degree ellipses, where the major axis staying constant and the minor axis changing. Back when I was in design school, I had to buy lots of ellipse templates. Luckily, you don't have to, but they're worth taking a look at, so I can talk about a few things. Okay, so I took this one out. So this is all 25-degree ellipses, right? So they're different sizes, but they're all the same degree ellipse. That means the major axis in relation to the minor axis proportionally is the same for all of these. So whether it's a tiny little ellipse or a larger one, these are all the same degree. They're all 25-degree ellipses. So what that means is that ratio of the minor to major axis determines the degree, right? So I could draw a rectangle to represent that, right? And I could fill that in with an ellipse like this, right? And I could take that same proportion, that horizontal versus vertical dimension, and I could make it smaller or larger and still have it be the same degree ellipse. Let's talk a little bit about, so supposed to be an eye here like that. There's some eyelashes. All right, this is supposed to represent the angle of vision, approximately 60 degrees. And this is the center of vision right here, which is I've mentioned before, is the horizon line. So the horizon line represents eye level of the viewer. And as an artist, you get to establish where the viewer is and what their perspective is. If we're looking at this cylinder here straight on, we're not going to see the top, right? So if we're looking at it straight at eye level, be skimming right over the top. Whereas if I had it above the center line of vision, or the horizon line, I'd start to see the bottom ellipse. And if it was below, I would start to see the top, right? If it was right in the center, where you don't see either the top or the bottom, like this, right? You don't have enough of an angle to be able to see the bottom or the top. But if you were to look at something transparent, like this, we'll pretend that that these are all totally even, but as it drops down, we start to see those different degree ellipses. You can see how you can very narrow degree here, a little bit more open, the most open yet. So as it goes down below your eye line, the ellipse gets bigger, and as it gets closer and closer right to your center line, it gets narrower and narrower, right? And of course, if it was completely perpendicular to the view, viewer like this, if that was the end of the cylinder, you would see a circle. Okay, so if you were to look at the object like this one right up in your face, you would see the most change in that object, right? You'd see the biggest change relative to the center line to the extremes of your cone of vision, right? So you see the biggest ellipses versus, the biggest differentiation between the different ellipses within the object. But the farther away that object is, like here, the smaller the slice is of your cone of vision. So you'd see less differentiation between the different ellipses. So the degree of ellipses depending on the angle of the viewer to the circle, making the different degree ellipses. The smaller and farther away the object is from the viewer, the less of a distinction between the different ellipses of one object that the viewer will see. And when you're drawing a cylindrical object, I find it easier, rather than worrying about all those different degree ellipses within one object, is to just find one that communicates the overall relationship of the object to the viewer, and then sticking with that. So have a center line, decide on what degree ellipse you want to draw, and then maintain that same ellipse for the entire object. Whether it's a small ellipse or a big one, keep the overall degree of the ellipse the same, will make your job a lot easier and usually be more effective for communication.